so for this one, let's walk you through some of the videos we put on here. I've lovingly curated some of the coolest videos that you will ever see in your lives. And so they're going to go in sections. This is the order we're going to do it in. Each of the groups is going to have its own little videos, and so that's where you find them. So we're going to do the crinoids now, so let's look at the crinoid videos. And rather than me actually opening these, because I'll get copyright claimed if I put them in here, I have now learned this. I'm getting better at YouTube. I'm going to point you to the links, and I'm going to say you got to watch these. You just got to watch these. They're too cool. So this is going to be some deep sea video, and you're going to see a bunch of crinoids in there. Look for the little 5-armed guys with a long stem and the little head at the top, which is where the mouth is and all the internal organs. The crinoid swimming down here is fantastic. It's just a short clip, but this is going to be one of those crinoids that evolves, and it has a stalk early on, and then it gets rid of the stalk as it's developing, and it just breaks free. And look at this thing move through the water. It is absolutely hypnotic. You will love it. You will want to show your family. You will want to paste this to your Facebook or whatever the heck you use page. Down here, this is just the best. So the Crinoid Walking. These are images of crinoids down in the very deep ocean. And when you think about a crinoid, so it's got that long stem that is actually thought to be analogous to the spinal cord in a human, like a long stem made out of discs that have nerves running down them and connect up to the rest of the body. So when you think crinoid stem, think spinal cord. When you think crinoid head, that is basically like our skull. And so it's got the hole where food goes in, and it does respiration inside of there. And it happens to also have all of its internal organs in there. So even its stomach and stuff are crammed inside the skull. And so you're going to watch this thing walking across the bottom, dragging itself along on the little arms that come out of the calyx, which is the top, that sort of round part at the top. This is basically a skull and spinal cord that drags itself along across the bottom of the ocean. And some of these images the lighting is perfect. It looks ghostly. They look like bones. They are fantastic, and you definitely got to see them. Shown down here are some of the problems that crinoids run into because they're successful, and so everybody wants to hop on somebody who's successful. Actually, crinoids were successful for a long time on Earth. They're not doing great at the moment, but they still get their share of parasites. Remember, we covered some of the annelid parasites of crinoids right at the end of the annelid section. And the other big problem with crinoids is they get snails, and the snails will attach to them. They'll often clamp down over either the crinoid's mouth or the crinoid's anus and just steal food or steal waste from the crinoid and feed themselves. And a lot of crinoids do not have a way to get rid of these snails. They're a menace, and the crinoids that have the snail on them do not live as long and do not grow as large, so it definitely hurts them. But here's a couple little examples in here from some nice deep sea footage. And then we've got a crinoid feeding. So this is somebody's private pet crinoid, and you can see the little orange bits of food, little brine shrimp or something, and they're going to be moved along those ambulacral grooves. So look for the little food particles to stick to the grooves and then move along in an orderly fashion as if they're going down a little highway. So there you go. That'll be crinoids. Now let's go and talk echinoderms in general and crinoids in specific. So we'll start our subtitles there, and there we go. Okay, so inside of a crinoid, you can see, here we go, this is the water vascular system. So it is outlined in blue because it's filled with water. How nice. And this is going to be a closed, pretty much closed system. But we are going to come up here and exchange some of this material at the top. We'll have this madreporite, which is the waste exchange. So any waste that's pumped out into this water vascular system is going to go up there. I would think of it as analogous to the lymphatic system in a human. We have this separate line of things like arteries and veins, but they're for white blood cells to travel down, and plasma, but not for red blood cells for the most part. And so we have separate places for these things to go and hang out. And yeah, that's kind of like what's going on inside of echinoderms. This is the inside of a tube foot, and so here you can see there's a little ampulla, which is like the ampule, like that little bulb at the top of a pipette. And so when the echinoderm wants to inflate this foot and actually use it to stick to something, there's something like a suction cup at the bottom that's going to be activated when they fill it with water. They're going to squeeze the muscles that are on either side of this. So it's this muscle here and this muscle here, the ampullary muscles. And that's going to pull down the top and squeeze all the water out of this and flood the water into the tube foot, filling it up. And then when they're done, the nerve up here is going to say, okay, muscles, you can relax. And so it's going to then release that, and the tube foot's going to go flat. So the echinoderm brain has to be complex enough to control entire arrays of tube feet. And some of these things seem to almost independently move. So imagine how hard it is to independently move your 10, fingers. And if you play piano or an instrument, something like that, you know this takes a lot of practice. Imagine now if you have absolutely hundreds of little fingers in the form of tube feet, and you got this weird ring brain, and somehow you're able to control it and actually make it work. That is pretty fascinating architecture there, pretty fascinating neural architecture. And a very interesting sort of neurological concept. Here's a close-up on one of those tube feet. You see the inside is just hollow because this is the part we're going to fill up with water or pull the water out of, and then this will just collapse down and be flat. Here's a fairly inflated tube foot, and there you can see that suction cup-like end on the back. And this is how they're going to use the tube feet to move along, and we actually have some videos, I think, in the starfish section of some of the tube feet on these and some of just of a starfish on the beach. They're going to retract the tube foot, and then they're going to inflate it and attach it to the ground, and then they will sort of angle it, and that sort of moves them along, and then they will retract the tube foot and move it to the other side, and then put it back down again, and bam. D and E are just like A in the first step and B, and so they can walk along on tube feet. And this is also how they're going to pass food along. It's going to be like walking, except that there's going to be food moving, and the food is always going to move down those ambulacral grooves. At the end of those grooves, it's always going to end in a mouth, and so that's how they're going to feed themselves. Here are some beautiful crinoids. So this one has a stem, it's a nice deep-sea crinoid. Here's our mouth is going to be in the center. Here is that deep-sea crinoid that was able to pull itself out of the ground, so it still has a stalk, but it's not rooted down to anything, whereas the earlier ones tend to be cemented onto something hard at the bottom of the ocean. And here are two of those feather stars. These are crinoids that have evolved past the need for these sort of ancient stalks. And they are free swimming, free floating. And you get some of these things actually on coral reefs. If you were in the Red Sea, for example, you might be able to see some of these crinoids just there in the wild. And that would be a really cool thing, I would think. So what's going on in there? Well, okay. Inside of each of those arms, you're going to have gonads. They're going to be all about producing babies. And this is going to be something similar inside of starfish. If we dissect a starfish, you will see that for the most part, they do have that water vascular system. They do have a little nervous system in there, but most of the arms are going to be packed with gonads. And they are all about having babies. Yeah, digest that food and have those babies. That is the main purpose of life. And then we got the arms here, and on the inside of the arms, this is going to be the ambulacral groove. So there we go. With the little cilia, they're going to move the food along. And the little tube feet on the sides, they're going to help to move that food along. And then there is a crinoid. And again, that's that same deep-sea crinoid that's able to pull itself out and drag itself along head first. And then there is the other kind of crinoid, and so you can see the tube foot is pretty much the same. They've shown you a little cross section here. Still going to have a little center, still going to have a little bone running around here, still going to have a little ambulacral groove in the top. But with the muscle control, they are going to be able to flap these things and actually levitate in the water. They can essentially fly through the water by flapping alternate sides of their arms at different times. It's a highly coordinated, probably learned behavior. And just as human babies learn to walk, little baby crinoids have to learn how to swim. It's probably really, really adorable. Okay, so that's all the extra stuff we're going to do about crinoids, and I just wanted to make sure you're introduced to them because they're wonderful. And then watch those videos and see all the other things they can do, please.